Hello, my name is Konstantinos Gaitanis and I'm working for BT at bt.com. And today I would like to introduce to you the IcpKit, which is a Swift library for interacting with the internet computer on iOS and on macOS. So here's our story. We wanted to create an iOS app that is a wallet, essentially. One of the currencies that cryptocurrencies that it would support would be ICP. So we started investigating how it was possible to do that. And we found that the internet computer works with a state which we can query and we can modify through HTTP requests. So that sounded pretty good and easy to implement. So we found the reference documentation of the internet computer, and we realized that there is a lot of things that are actually not very straightforward. Some of these include the encoding, which is done using Candid, then the serialization, which uses CBOR. Then we have order independent hashing that to calculate the hash of the requests that we make to the internet computer. We need to sign some of those requests, especially those that modify the state, which involves elliptic curve signatures. We need to parse the response, which are also presented as a CBOR serialized Candid. And finally, we also need to verify the BLS signatures that are used by the internet computer to certify the responses of our requests. So this is not very straightforward and certainly not accessible to most of the iOS developers. So the solution was to create IcpKit. IcpKit is a Swift package that implements all this functionality and allows us to abstract away the complexity of the internet computer requests. So basically this will allow our devs to focus on building the app, effectively making the development for iOS and macOS much faster. And so here we are now. The IcpKit is published and it's open source and available on GitHub. You can find the link in the description. So let's start with a demo of the IcpKit. This is a little sample app that you can also find in the repository. So on the left, you can see the relevant code about this application. It's very simple. And on the right, you can actually see the app running. So we start by importing the IcpKit using the import setting, like every other Swift package. Then we create a signing principal. This is a self-authenticating principal that we create from our public key that is derived from our secret phrase. Then we create the account using the icpaccount.main account method. And as the name suggests, this creates the main account of this principal. And here in the app, you can see this is the address of this account. Next, if we want to interact with the internet computer, we create a client. This is the HTTP client that will take care of the serialization and encoding and signing of all the requests. So in the IcpKit, we have already implemented the ledger canister. And here we demo calling two of the methods, the account balance and the transfer method. So in order to get the balance of the account, we have two ways of doing it. The first one is creating a call request to the internet computer and then polling the state of the ledger canister until a response is formulated for this request. So in the demo app, you can see this. If I push the call balance button, this creates the request and continuously polls until the state is updated, and here you can see the balance. We can also do this in an uncertified way, which is basically a query request, which is supported by the ledger canister. Here you can see it's much faster, but then again, the response is not signed by the internet computer. So this means that anyone could send us this response. It depends on what kind of usage. Sometimes queries are good enough. Sometimes we need to make a call request. This depends on the implementation. And finally, I will demo a transfer. So basically, here we are modifying the state of the internet computer. So to do this, we need to sign the request. And here we call the transfer method of the ledger canister. So we provide the from account, a to account, the amount that we will send, the principal that is signing this request, and the client that we will use. And it's that simple. If I click the transfer button, then this will send the request and wait until it has been processed. Here we see the response is the transaction block where the transaction was placed. If I query my balance now, you will notice that the fees have been subtracted from my balance. This is normal because I sent a transaction from my account to my account, so only the fees are being deduced. And we can check on the Internet Explorer for this transaction just to make sure that we have received it. And here you can see that indeed this transaction was registered on the Internet computer. So that was a quick overview of the IcpKit. This can be used basically to build iOS apps that interact with the Internet computer. Next steps is to support Internet identity. For the moment, we only support self-authenticating principals. We would also like to add the support for IC tokens as well as NFTs. That's it. Thank you very much for your time, and I wish you happy coding.